Hello, everybody, and welcome to Trigonometry, Angles, and Ratios Lesson 2. So today we are going to look at the trigonometric ratios, So last year in grade 10, you looked at these. These were, I don't know if you remember, sine, cos, and tan. So we are going to be looking at these for angles from 0 to 360. This is a long lesson. I might flip it into 2 videos. We'll see how I feel when I get to the second page here. Or I might just push on and make a long video. Who knows? All right, so we know the traditional formula for the Pythagorean theorem is c squared is equal to a squared plus b squared. And this is looking at the sides of a triangle and calculating the sides of a right angle triangle. In trigonometry, we are going to use x, y, and r instead of a, b, and c. So I'll show you what I mean by that. So on this diagram here, we have an angle, and that angle, that's the terminal arm there. It creates this angle here, and what you can see is actually that xy point here. That's an xy point. We use those coordinates to form a triangle. So we've got the x component and the y component. It's a right angle triangle. So you can say, if we wanted to find the value of r, or how far, or the distance from the origin to the point up there, we could say x squared plus y squared is equal to r squared. That's the Pythagorean theorem. We're going to be using that in the next couple of pages here. So it says here, sketch the rotation angle and standard position and calculate the exact distance from the origin to the given point. Where appropriate, write the answer in simplest mixed radical form. Yay, good thing we did radicals. So let's draw this. We have an xy plot. xy. Our point is negative 5, 12. So if I draw that on my diagram, let's say x is negative 5 is over here, and y is 12 is over here. So that point is going to be somewhere right there. So what we're looking for is the exact distance of, we'll say, d, of that. And we know that along the bottom, this is negative 5, and all the way up is 12. So in this case, we're just looking for the distance. The negatives don't really matter. You're going to be squaring it anyway, so if you do incorporate the negative, it's going to disappear. But we know that Pythagorean theorem states that d squared is going to be x squared plus y squared. So to find that distance, we have to use Pythagorean theorem. So we can say, okay, well, d squared is going to be 5 squared, that's my x, plus 12 squared. What's going to happen is that's going to give me a d squared of 169. And then in order to find the value of d, we have to square root both sides. So we're left with d is equal to the root of 169. And lucky for us, that is a perfect square. So d is 13. So we're just using Pythagorean theorem, but we're going to put it onto a coordinate system here, and yeah, you can go from there. So the next one, we'll do one more. I'm trying to move through these quick because this will be a long video otherwise. We have our xy. We're going to plot our point. I'll do it in blue. So it's negative 2, negative 6, which means we're going to be negative 2 on the x and all the way down to negative 6, somewhere down there in the y. So it's going to look something like that. We're trying to find that distance, so I'll label that d. And we know that this right here is 2, that is 6. This is our angle, which we're not going to use, but it's good to remember. So now we have d squared is equal to x squared plus y squared, or 2 squared plus 6 squared, which gives us 40. So now we know that if we square root both sides to get d, then we're going to have root 40. We want to write this in simplest mixed radical form. So now this isn't the wrong answer, but it's not in simplest form, so you're not going to get full marks. You want to reduce this root 40 into simplest radical form. So we know that root 40 is the same as root 4 multiplied by root 10. So d is equal to 2 root 10. It's better to give it in radical form, because if you were to type this in your calculator, you would get some long irrational number, a decimal that never ends. So if you give me a decimal answer, that's a rounded answer. It's not exact. Whereas 2 root 10, this is an exact answer. And if you can give an exact answer, you might as well. All right. So just a quick review of the trigonometric ratios. We talked about them a little bit at the very start here, but we have the sine ratio, the cosine ratio, and the tangent ratio. So it always depends on what your, I always called it a reference angle when I was teaching this, what your angle that you're using is. So in this case, this is the opposite side from the angle. This is the adjacent. It's between the angle and the right angle, and across from the right angle, we have the hypotenuse. So you remember SOHCAHTOA, SOHCAHTOA. So that means sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And tan is opposite over adjacent. TOA. Tan is opposite over adjacent. These are called the primary trigonometric ratios, and we can remember them with SOHCAHTOA. In terms of x, y, and r, if we look at this triangle down here, what happens is y becomes our opposite, x becomes our adjacent, and r becomes the hypotenuse. So that means sine of theta is not opposite over hype, it is y over r. Hopefully that makes sense. Cosine is adjacent over hypotenuse, but we're going to label it as x over r. And then tan is opposite over adjacent. So we're going to get y over x. So you are going to have to memorize these formulas. You can always draw this triangle. You know if you draw this that, that is the x, that is the y, because that is the change in the y-axis and the change in the x-axis. And r represents the radius. Another way to remember it is 7 yellow rabbits. Sine is y over r. I've never heard that before, but the book seems to like it. So there we go. I'm going to push through and make this one long video, I think. I think that's what we'll do. I'm not sure how far we are in. I can't actually check that, but we're going to push through. All right, the point 15.8 lies on the terminal arm of an angle as shown. Calculate the value of r and hence determine the exact values of the primary trigonometric ratios. So this point they're saying right here is 15.8, which means the x value is 15, the y value is 8. We need to know the r value before we can do any trig ratios. So in order to do that, we can use Pythagorean theorem. R squared is equal to x squared plus y squared. So r squared is 15 squared plus 8 squared. And if I solve that, I get 289. And then I'm going to square root both sides. And I'm left with r is equal to, the square root of 289 is 17. So that's kind of nice. That means r is 17. I went through that really fast because we've done a couple of those examples. Now what we can do is we can do our sine ratio, our cos ratio, and our tan ratio, because now we know all the values. So we know sine is going to be y over r, which is going to be 8 over 17. Cos is going to be x over r, which will be 15 over 17. And tan will be y over x, which will be 8 over 15. Awesome. First half done. The next half is for 3.5 pages. It's all right, we can do it. Investigating trigonomic ratios. Wow, I don't know why. Trigonometric ratios. I don't know why I can't say that. For angles between 90 and 360. So part 1, we are going to look at this angle here. They've got a diagram, which is really nice. And it's a point where x is 1 and y is root 3. So it says here, show that the value of theta is 60 degrees. Show that that angle is 60 degrees. So I don't know if you remember, we can say, well, if we know the x value is 1, and we know the y value is root 3. So if we know x and y, that is a tan ratio, right? Tan of theta is equal to y over x, y over x. So in this case, y is root 3, x is 1. So what we can do is, if tan theta is equal to root 3 over 1, or just root 3, then you can do the inverse tan, sorry, I just wanted to check, the inverse tan of root 3 to find that angle, and that will give you 60 degrees. That's the second function tan. I don't know if you remember that. Second function tan. And it does the tan to the negative 1. Calculate the value of r. So we are going to have to do the Pythagorean theorem. So r squared is going to equal x squared plus y squared, which will be 1 squared plus root 3 squared. So that'll be 1 plus, if you do the root, or the square a root, those end up just canceling each other out. So you'll get 1 plus 3. So that leaves us with r squared is equal to 4, square root both sides, and we have r is equal to 2. So now we know that x is 1, y is root 3, and r is 2. So the sine of 60 is going to be root 3 over 2. The cos of 60 is going to be x over r, which is 1 over 2. And tan of 60 is going to be y over x. So root 3 over 1, or just root 3 if you want. Now what we're going to do is we are going to reflect this in the y-axis. So instead of doing positive 1 and positive root 3, we're going to flip that point to the other side of the y-axis. So that means our x is still going to be 1, but our y is going to be, that's a lie, our x is going to be negative 1, and our y is still going to be root 3. So the coordinates are going to be negative 1, root 3. In this case, the reference angle is, well, the angle up here we said was 60. So that means this is going to have the same reference angle, 60 degrees. And that means the rotation angle is going to be 180 minus 60. And that gives us a rotation angle of 120 degrees. We know all the sides now. So we know if x is negative 1 and y is root 3, r is going to equal 2. So now we can just write our trig ratios in. So sine of 120 is y over r. That will be root 3 over 2. And you can see that's the same in both. Cos is going to be x over r, which will be negative 1 over 2. So it's almost the same, but cos is negative now. And tan will be y over x. So root 3 over negative 1, or negative root 3, which is almost the same, but not quite negative. So the only one that stayed positive is the sine. And you can confirm this on your calculator if you want to. Part 3. So we're going to do the same thing, but we're going to reflect in the y and the x. So now what happens is same distances. So x is -1, but now y is going to be -√3. So our coordinates are going to be -1, -√3. The reference angle is 60 degrees. It's still that section right there. And the rotation angle is going to be 180 plus 60, which gives us 240 degrees. So now we are just going to fill out our trig ratios, y over r. So we know r, again, is the same thing. It will be, 2. So now in this case, the y value is -√3 over 2. The x is -1 over 2. And the y, or the tan, is going to be y over x, which is -√3 over -1, which is actually the negatives cancel out and it becomes +√3. So you can see now this time our sine is negative, our sine ratio, our cos ratio stays negative, and our tan ratio is positive again. There is a pattern here. We are going to look at it in 1 second here. Maybe more than that, in 3 minutes. All right. Part 4. This is the same thing. So now we're reflecting just in the x-axis, which means this S point is going to be +1. And y will be -√3. So 1, -√3. The reference angle, again, is 60 degrees. And the rotation angle is going to be 360 minus 60. So we have a rotation angle of 300 degrees. So that means the sine of 300 is going to be y over r. And our y in this case is -√3 over r, which we know is still 2. So -√3 over 2. Cos of 300 is x over r. X is 1, r is 2. And tan is y over x. So that's -√3 over 1, which is -√3. So now in this case, sine is negative. The cos is turned to be positive, and the tan is negative. So you can actually see outside of quadrant 1. So in quadrant 1, everything was positive. All 3 ratios were positive. In quadrant 2, only sine was positive. In quadrant 3, only tan was positive. And in quadrant 4, only cos was positive. So they actually all have their own quadrant where they're positive, and we'll talk more about that. There's a good way to remember that. So let's have a quick look here, and we'll start in quadrant 1. So in quadrant 1, this is exactly what we just talked about, sine y over r. So r will be positive, x will be positive, y will be positive. And in this case, x is going to be negative, y will be positive, and r will be positive. And in quadrant 3, both x and y will be negative, and the r will be positive. And in quadrant 4, the x will be positive, the y will be negative, and the r will be positive. So you can see in quadrant 1, sine is y over r, which is positive over positive, and that gives us a positive. Cos is going to be x over r, and that's positive over positive, which gives us a positive answer. And tan is y over x, which is positive over positive, and that gives us a positive answer. So all the ratios are positive in quadrant 1. In quadrant 2, sine is y over r, which is positive over positive. Sine is a positive overall value. Cos is x over r, where x is negative and r is positive. So we have a total overall value of negative. And tan is going to be y over x, where y is positive and x is negative. So we have an overall negative value. So you can see in quadrant 2, only the sine is positive. The rest are negative. In quadrant 3, just go through this quick. Sine is y over r. Y in this case is negative. R is always positive. That gives us a negative. Overall value cos is x over r. X is negative. R is positive. So that gives us a negative overall value. And tan is y over x. And so in this case, y is negative, x is negative, and tan is positive. So in quadrant 3, the only positive ratio is tan. And in quadrant 4, one last time, sine is y over r, and we know the y is negative, the r is positive, so we have a negative overall value. Cos is x over r, x is positive, r is positive, cos is a positive value, and tan is y over x. So that's negative over positive, so we get a negative overall value, and that means that in quadrant 4, the only positive value is cos. And there's a way to remember this. We'll talk more about that. I'm going to skip this part. If you want to do this part, go for it. You can fill that in. We just did that on the last page. The cast rule. Okay, cast. So there's a couple different ways to memorize how this works. Cast is this. Cast. So that means in quadrant 1, all ratios are positive. In quadrant 2, the sine ratio is positive. In quadrant 3, the tan ratio is positive. And in quadrant 4, the cos ratio is positive. You do need to memorize these. Some people, I've never heard this, but I kind of like it, add sugar to coffee. So this actually starts in 1, and then 2, and then 3, and then 4. So that's a little bit nicer way to do that. Add sugar to coffee. And then it says here, determine without technology whether the given trigonomic ratios are positive or negative. So sine of 340. So if we look at XY plot, or yeah, an XY grid here, we have 0, 90, 180, 270. So sine of 340 means that it's going to be in quadrant 4. So at sine in quadrant 4, the only ratio that's positive in quadrant 4 is cosine. So this will be negative. Tan of 227, which is going to be in quadrant 3. Tan is the only positive one in quadrant 3, right? We can do our add sugar to coffee. So in quadrant 3, tan's positive. That's going to be a positive ratio. Sine 88, which is going to be in quadrant 1. All ratios are positive in quadrant 1. Yay. Hopefully you get the gist. Try the last 3. I'm not going to do them. I'm going to skip over them. Okay, I think let's bomb over to rewriting the same trigonomic function of an acute angle. So what we're doing here is we're rewriting the trigonomic function using the reference angle, and it should give you the same answer, but you do have to change it to be positive or negative, depending on which part of the cast rule it sits in. Sorry, I'm kind of rushing. This is a long video. So in this case, we have sine of 140. 140 is kind of out here somewhere. So we know the reference angle is going to be, ref angle is going to be 180 minus 140, which is 40 degrees. So we can rewrite this, sine 140, as sine of 40, and because it's in quadrant 2, Q2, that's where sine is positive. So we can just leave that as sine of 40, and that should give us the same value. Tan of 323. So let's have a quick draw here. 323 is somewhere over there. So that's going to be our angle, and our reference angle is going to be that. So in this case, the reference angle is going to be 360 minus 323. So that gives us a reference angle of 37 degrees. So we can rewrite this as tan of 37, but you can see that in quadrant 4, this is in Q4, only cosine is positive. So this needs to be negative tan 37 if you want to use that. All right, let's do a cosine. I'll do E and then we'll call it a day. So if we draw here, we've got cos of 308. 308 is somewhere over there. So that means our angle, that's 308. Our reference angle is going to be 360 minus 308, and that gives us 52 degrees. So we can rewrite cos of 308 as cos of 52, and we got to make sure it's positive or negative. So in quadrant 4, cos is positive, so we're just going to leave it the way that it is. Yay! Hopefully this made sense. So the whole idea behind this is that when you do that, you get the same answer. So if you do, sorry, I was just double checking. If you do cos of 308, it should equal cos of 52. If you do from over here, tan of 323, it should equal negative tan of 37. And you can check those on your calculator if you want to. Okay, that's it. I'm stopping. We'll do some practice problems and hopefully it starts to make sense. Have a good night. Don't forget to like and subscribe.